think I'm gonna need to turn it like this to see the board. Journey, I'm gonna give you consequences if you do that again. I don't know if they'll be able to see the board from there, but maybe. All right, so Adam's family. Everything we know of is made of atoms. What is an atom? Somebody tell me. Adam, Tanner. Speak very loud.
It's made up of protons, neutrons, and electrons.
What is it though? For instance, if I say what is a human, then I don't want to say a human is eyes and ears and nose and mouth and knees and toes and hair and what? Spit.
Everything that makes up the world.
Everything. Stuff that makes up everything.
Objects.
Yes. Okay, so the tiniest thing you can break something down into, but it makes up everything. Okay, so it's made of protons, neutrons, and electrons, which is what we're talking about right here. So, in the center of Matterville, there is the nucleus arcade. The nucleus basically is the center. And there you will find two members of the Addams family, Perky Patty Proton and Nerdy Nell the Neutron. Perky Patty, like her sisters, is very large with a huge smile and eyes that sparkle. Patty is always happy and has a positive personality. So inside the nucleus is
Proton.
a proton. Now I'm going to have to draw this probably large for folks at home to be able to see this. Here is the nucleus of an atom, and inside it is large protons that have what kind of charge?
Positive.
Positive. Okay? Let me make sure they can see it. I might need to move it a little bit closer. Oh, we're going to have to move that way closer. And I don't know how we're going to do that and still be.
Use a desk, like scoot it up. Oh, use that desk.
I just don't know that we can get it that much closer. That's about it. I'll put it right there. All right. So protons in the middle. Then remember I said that we also have Nerdy Nell the Neutron that likes to hang out in the nucleus. And Nerdy Nell the Neutron, like her sister, is quite large, eyes with zero expression, a flat mouth, and her family is very apathetic and neutral about everything. So what else is inside that nucleus besides those positive protons?
Neutrons.
Neutrons. Are neutrons big or small? Big. Okay. And what charge do they have? Neutral. No charge. Zero. Okay. So, around the outside of the nucleus are a series of roadways that are actually invisible. And there is a member of the family that likes to ride around those roadways on his bright red chrome-plated Harley Davidson. His name is Enraged Elliot Electron. Elliot is much smaller than Patty and Nelda, is always angry because they won't let him in. He has a frown on his face, eyes squinted in anger, and a very negative attitude. So where is this electron? Where does it like to hang out? Around the nucleus. And is it big or small?
Small.
Small. And what kind of charge does it have?
Negative.
Negative charge. So that is your atom. Now, those roadways, there are a series of them. They're typically called energy levels, orbits, or shells. And just like during the COVID when we have to stay 6 feet apart, those electrons have to stay 6 feet apart too. Okay? Or more. That first energy level, the energy street, the one closest to the nucleus, can only hold 2 electrons because they have to keep their distance, socially distanced. The second one, the energy freeway, can only hold 8 electrons. It is a little bit bigger than the other. And the biggest one, the energy superhighway, can hold 18 electrons. Now, most atoms, especially the ones from the periodic table, will have the same number of protons as electrons. So if you look on the periodic table of elements, in those little boxes, that top number, the atomic number, is the number of protons. But it's also the number of electrons. Okay? So let's say you have, like this one here, you have 4 protons with what kind of charge? Positive charge. And you also have 4 electrons with negative charge. Okay? Each positive cancels out a negative, leaving it with what kind of charge?
Neutral charge.
No charge. Zero. Neutral. Okay? So, what would happen if one Elliott electron was kidnapped? What would happen to the charge then?
It would be more of a positive charge.
It would be more positive because now you have more positives than you do than negatives. In fact, it would have a positive 1 charge because there's 1 more positive than negative. What happens if 2 of them get kidnapped? What kind of charge then? Positive 2 charge, yes. Now, anytime you have more positives than negatives, that's called an ion, not a neutral atom. Okay? Now, next slide. Okay, let's say that you have 1 Elliott electron move into Matterville. Now we have more what? More negatives than positives. So now it has what kind of charge? Negative charge, negative 1 charge, because it has 1 more negative than positive. What if 2 electrons moved in? Negative 2 charge. Is this a neutral atom or an ion? A negative ion. All right, questions? Let's skip through the atomic math challenge. All right, so I'm going to put it right back here because I need to show the board. Okay, so the atomic math challenge is based off of the periodic table. Need my mouse. Actually, okay. This periodic table shows all the elements that we know of on Earth. They are organized by their atomic number, which happens to be the number at the top of the box. So see that number at the top of the box? Mm-hmm. For the big one right there at the top middle. Okay, the top number 6 is the atomic number. That is the number of protons. That is how the atomic or the periodic table is organized, by the number of protons. If you'll notice, this one has how many protons? What's its atomic number at the top? 1. This one has how many protons?
2.
This one has how many protons?
3.
How many protons?
4.
How many protons?
5. 6, 7, 8, 9, 10.
10 what?
Protons.
Protons. What's its atomic number? 10. Okay? That's how the entire periodic table is organized. By atomic number, which is also the number of protons. But it's also the number of electrons if the atom is neutral. Okay? Now remember, you can lose electrons. They can be kidnapped. You can gain electrons. They can move in. Right? So that number can change. But it's always the number of protons. Gotcha. All right. With me so far? Okay. Now, this periodic table is also organized different ways. It's not just by atomic number and you read it like a book, top row, second row, third row. It's also organized into columns like this, or this, or this, and rows. Every element in this first column has one characteristic the same. Think of it like this. If I were to put you in columns based on hair color, all the folks with brown hair here, all the folks with brown or blonde hair here, would all the brown haired people have exactly the same characteristic? No. They'd all have brown hair. Some of them would be boys, some would be girls. Some would have blue eyes, some would have green, some would have brown, some would be tall, some would be short, some could play basketball, some could play soccer, some are just big video game fans. Same thing for the blonde hair people, right? Well, that's what is true with this periodic table. Every single atom of this element right here, Journey, has one characteristic in common. That's why they put them in that column together. Every single element that's in this row with potassium and iron and krypton all have one characteristic in common. Now, it just so happens that potassium has one thing in common with this row and one thing in common with this column. And they're also grouped into bigger groups, like all of these guys are metals, because they all have characteristics of a metal. These guys are non-metals because they have characteristics of, of things that are not metals, okay? So basically the periodic table is grouped by similar characteristics. They put them in rows because they have similar what? Characteristics. They put them in columns because they have similar characteristics. They put them into big groups because they have similar characteristics. Just like you are in this classroom right now because you all have a similar characteristic. You are all sixth graders. Good job, Cash. John?
Is every periodic table going to be organized the same way?
Every periodic table is exactly the same unless it's an old one and they don't have the newer stuff from the elements. For instance, scientists are looking at, do you see all these that say U? Okay, these are all ones that have been discovered, but they don't know everything about them yet. So they do know how many protons. They know some of their masses. This one, they don't have the mass yet. Okay? But they don't even have a name for it, or they're waiting to name it, or it's been named and somebody hadn't updated it. So there's a lot of things, like once they discover new stuff that they've never seen before, they have to find out things about it, like how many protons, neutrons, electrons, what is it? Its atomic mass, which is, by the way, the number of protons plus neutrons. So the nucleus, what's in the nucleus? That's its mass. Those electrons, they're so little they don't weigh anything. They don't matter. Yep.
If you can't see an atom, how do they get the atomic number?
Okay, so they do have atomic microscopes that can see that small. Like super duper microscopes. Just like they have super duper telescopes that can see across galaxies that far away. Yes, super powered. Can you imagine seeing that small? I mean, you're made of billions of atoms. Could you imagine seeing every atom you're made of?
Wait, so that was like...
You can see your cells under microscope, but you need an even more powerful microscope to see the atoms that make up each cell.
So if I
for instance,
stuck my hand up...
Hang on, Tanner. I was talking. Give me 1 minute. So inside a cell is basically the basic structure of every person, but they have things in it like a section of water. Well, what is water made of? Hydrogen and oxygen. Those are two atoms, actually 3 atoms, H2O, that are combined together. That's just one molecule of water. Well, there's multiple molecules of water inside that cell because your body's full of water. Mostly water, in fact. So you're mainly made of H2O. Okay, lots and lots of molecules that come from atoms combining 2 hydrogens and 1 oxygen. Does that make sense? Okay, I hope so. If not, tell me. I can draw some things out and stuff too. John, you have a question?
Is it always going to be that you have to have an atomic microscope to see your atoms, or...
Unless you have a superpower that we don't know of that allows you to see on the atomic level. I mean, I am a superhero ninja Jedi, but that's not my superpower. Teaching is my superpower. The force, that's my superpower. Yes, Tanner?
So with that one's super microscope, like I could stick, for instance, like this eraser or the pencil down, and I could see like particles or.
You could see every atom that makes up the pencil. Every atom that makes up wood, every atom that makes up graphite, every atom that makes up the, well, you see aluminum, because I think the metal part close to the eraser is actually made of aluminum. But yes, you would see it all. I think instead of going to the board, I figured out another way to do this. I'm going to pull up the Smart Notes and write it on here. I just need a second.
Smart.
Because it's smart like that. Hey. All right, I'm going to grab a stylus. And we're going to talk about the Atomic Math Challenge. You know what a stylus is?
It's like pen with this rubber thing.
Yeah. We're so smart. Man. Okay. Atomic Math Challenge. I'm going to do a split screen. How do I do that?
Go to the tab, press that, and then you slide it around the right.
I'm going to put it over here.
And then you let it go in there. And you do this, and you do that.
Yes.
And there you go.
All right, I'm going to turn the camera off so that we're only concentrating on what's on the screen. All right, so Atomic Math Challenge. Here we go. Inside each of those boxes on the periodic table, you have an atomic number, the number at the top. You have the symbol, you have the name, and you have an atomic mass. Now, some of those elements on the periodic table are a little confusing. Like the symbol for gold is AU. Oh, it won't let me. Okay. That is the symbol for gold. A lot of the weird ones like that come from Latin names. You remember that from the video? Good job. All right, so here we have atomic number 8. We have symbols O, name oxygen, atomic mass of 15.999. Folks, remember, half of your test is going to be this Atomic Math Challenge. If you pay attention to nothing else, what do you need to pay attention to? This right here. That atomic number is the number of protons. Remember, atomic number equals protons. Always the number of protons. Sometimes the number of electrons. Because they can always lose electrons or gain them. So for this particular element right here, oxygen, how many protons does it have? 8 protons. Now remember we said it's the number of electrons too, so how many electrons? 8. And how do we find the number of neutrons? Does anyone remember? Do you remember, John?
You have to subtract the atomic number from the atomic number from the atomic mass.
From the atomic mass. You're right. Let me go here. I'm going to erase this. Okay. So atomic mass. Do you mind if I abbreviate?
Yeah.
Okay. Atomic mass minus atomic number gives us the number of neutrons. And here's why. That atomic mass actually is the number of protons plus neutrons. We just want the neutrons. So just like if I had an apple and an orange and I only wanted the orange, what do I need to get rid of? The apple. How do I get rid of the protons? I subtract them from the equation, right? I get rid of them. So if I subtract the protons, what am I left with? The neutrons. That's why you subtract the atomic number from the atomic mass because the atomic number is the proton. So essentially, we're subtracting, watch this. The atomic mass is protons and neutrons, and what is the atomic number? Protons. If I subtract that, that's gone, and I'm left with this. So atomic number from atomic mass gives you neutrons. Got it? So let's do some practice. And I know you've probably done some of these already at home, but we're going to go over them again to make sure you understand how to do this. Got it? Okay. If you are looking at zinc, right here. Oops. What is the atomic number? Which of the ones in the box is the atomic number? Okay. Avery. 30. The number at the top is atomic number. Well, which one of those numbers is the atomic mass? Cash?
The one at the bottom.
Atomic mass. Oh, that's like atmosphere. Is 65.39. Okay, how many protons does it have? Which one of those numbers in the box is the protons? Okay, Madeline. The atomic number at the top. Top protons. Kirsten, you with us? Okay, this is protons. It's also electrons. Yes, so 30. And electrons is also 30. Now, how do I find those neutrons again? Subtract that 30 from 65.39. Right? Anna? Yes? Okay. So 65.39. Where do I put the 30? It's a whole number. It goes under the other whole number. And what is after that 30? 2 invisible zeros. So I'm left with 35.39, or we could round that to 35. Okay, let's do the next one. Lithium. Which one of those numbers in the box is the atomic number? 3. Atomic number? 3. Which one of them is the atomic mass? 6. The other number, 6.941. Okay, which of those two numbers is the number of protons? 3. Which of them is the number of electrons? 3. How do we find the neutrons? Subtract 3 from the other number. 6.941 minus 3 gives us 3.941 because that's zeros. Right? Easy peasy? With the side of? All right. John, you have a question?
Wouldn't that be like, it wouldn't have the charge at all, like if it was the same number?
All of these are considered neutral because they're like the ideal atoms. All the ones on the periodic table. We know that atoms are not all like that. For instance, lithium, the one we just did. Have you ever heard of a lithium-ion battery?
No.
Guess what element is in the lithium batteries? Lithium. And it's called ion because it's not a neutral atom. It's either got more or less electrons than the protons. Crazy, right? All right, let's do this one. Here we go. Make sure you're paying attention. Silicon. Okay, silicon. Which one is the atomic number?
14.
Anna, which one's the atomic number for silicon? 14. Which one is the atomic mass? Atomic mass, Journey. We're talking about silicon over here, buddy. If 14 is the atomic number, what's the other number there? Right here, this box. There are two numbers. We have 14 and we have 28.086. If 14 is the atomic number, which one is the atomic mass? 28.06. Oh, wait, 086. All right. So which one of those two numbers is the number of protons? 14. Which one of those is the number of electrons? 14. How do we find the number of neutrons, Journey? We've only got two numbers. That top number 14 is the number of protons and electrons, not the number of neutrons. How do we find the number of neutrons? Okay, we have 14 is protons. 14 is electrons. That atomic number is the number of protons. The atomic mass is protons plus neutrons. We just want the neutrons. What do we need to get rid of? We have protons and neutrons. We just need neutrons. What do we get rid of? We have apples and we have oranges. If we just want the orange, what do we get rid of? The apple. So if we have neutrons and protons, but all we want are the neutrons, what do we get rid of? The protons. Let's subtract them. Let's get them out of there. Now they're gone. All that's left is the neutrons, right? So that atomic mass is both of these. That atomic mass is 28.086. What did you tell me we have to get rid of for the atomic mass to just be the neutrons? Okay. Which one of those numbers is the number for the protons? 14. So we subtract 14 from that and we're given 14.086 for the number of neutrons. Okay. Looks like we're going to need to do one more, because this is half your test. Here we go. Let's do bruh. Let's do bruh or bromine. For all the boring people, bromine. For all the cool people, we're going to call it bruh. All right. Here is our periodic table box. Which of these numbers is the atomic number, Kirsten? Which one of those two numbers is the atomic number?
35.
Atomic number. Which one of those two numbers is the atomic mass, Tristan?
79.9.
Gotta be, because the other one's the atomic number, right? Which one of those two numbers is the number of protons, Madeline?
25.
Which one of those two numbers is the electron, Anna?
35.
Also 35. How do we find the number of neutrons, Liam? We add these two together. That would give us 70. We don't have any numbers here that are 70. That's the number of protons and electrons. What is this? But we just want this, so what do we need to get rid of from that? We get rid of the protons, so let's subtract the number of protons from that, which is what number? So we subtract 35 from that number, and we're left with 44.904. Okay, one more. Let's do one more. Last one. Let's do this one. Let's do the boron, not to be confused with moron. Okay. 5B boron 10.81. Okay. Which of these numbers is the atomic number, Madeline? 5 is the atomic number. Which of these two numbers is the atomic mass, Journey?
10, 5, 81.
Yes, sir. Which of these two numbers is the number of protons, Kirsten? 5. Which of these two numbers is the number of electrons, Tristan? 5. Which of these two numbers is the number of protons plus neutrons, John?
The number of protons and neutrons?
Yes, together.
Well, the protons would be 5, right?
Yeah, that's 5.
And then that, you have to subtract.
No. Which one is both the protons and the neutrons already? You only have two numbers to choose from. We know that this one is the protons, so that can't be it.
The atomic mass.
So this is protons plus neutrons. How do we get the neutrons by itself? Liam, how do we get that by itself? What do we get rid of? This or this? Do we need to get rid of the protons or the neutrons? Get rid of the protons.
We're getting ready to start
Okay.
our dismissal
How many protons?
process. Can I have students?
5. So 5 minus 10.81. 5.81 is the number of neutrons. Easy peasy. With a side of?